Okay, so last time we talked about mesh or nodal analysis for solving circuits. And they said that although they are alternative methods for giving us both the current and voltage everywhere in a circuit. But there's some certain circuits that make mesh or nodal analysis a little more complicated. So with mesh analysis, we're really doing KVL. Remember, we're Kirchhoff's voltage law, so summing voltages across a loop. And that makes it really easy to do when you have voltage sources and then just resistors, but it's harder when you have current sources like this guy here. So if I have mesh analysis, if I want to do mesh analysis and I have current sources, I have to do something special. If I have a special case, which I'm going to call case 1 here, that the current source only involves one mesh, it doesn't overlap with multiple meshes, then that mesh's current can be defined by just that current source's value. So if I go in here and I make, here's my mesh I1, and here's my mesh I2, then this current source really only interferes with I1. It doesn't interfere anything with I2. My next question to ask myself is which direction is that current source going compared to how I've drawn my arrow for I1? Well, I1 was going clockwise, so through this, it really goes up in my leftmost branch, right at the top, down through my rightmost branch, and then left through my bottom branch. Since my current source is also going up in that same branch from it, it's in the same direction as I1. So I can write that my mesh current I1 is just equal to 1 milliamp. Remember, milli is 0.001. So I already know what I1 is. I don't have to write equations for it. I would only have to write equations for I2, which again for that would be that 4,000. If I start down here and go up through here, that's my 4 kilo ohm, onto I2 minus I1, since I want I2 to be positive, plus 8,000 I2 plus 16,000 I2 would equal 0. I now have two equations. Here's one equation, here's my second equation, and two unknowns. But it's really only like one equation and one unknown, because I could just plug this value in for I1. Easy peasy. Case number 2 with current sources and mesh analysis is a little harder. If I look at this current source here, it is not just overlapping with one mesh like in my first current source. I'm going to delete my chicken scratch so we can just see what we're doing here a little better. It overlaps with two meshes. So if I make this I1, then here's mesh I2, then here's mesh I3, then here's mesh I4. This current source overlaps with I1 and I2. So I have to then look at how does it relate to both of those mesh currents, I1 and I2. So I first have to write an equation for how the current source relates to the directions of these mesh currents, and it should overlap with multiple meshes here. So in my case, this guy's value is 1 amp, or just 1, and that equals, well, is it going in the same direction as I1 through that branch? Yes, it is. Through the bottom, I'm going to the left from it, so it's same direction as I1, it's positive for I1. It's the opposite direction as I2 is going through that branch, because it's going clockwise this way, right? So minus I2. And that's what I would write. That gets me one equation. And then I actually remove that mesh source. So I'm going to draw it like, remove that current source so like it's not there. And I make a super mesh going all the way around now in my loop. So what does that get me from my super mesh equation? This is called a super mesh. When I remove that current source, it removes anything in series with it. It basically gets rid of that whole branch as if that whole branch isn't here. So I'm actually going to draw that in white so it looks like I've erased it instead of black. Okay, so now nothing's there. Even if there was a resistor in series with that current source, it will go away. It removes that current source from it. Now I'm going to do my whole big loop of this super mesh. So what equations do I get there? Start at my bottom left-hand corner, I hit 100 ohms. So that 100 ohms, I still have to remember where I've defined I1 and I2 because it is not the same current. That current source was there. I'm just pretending like it isn't there to do this. So the 100 ohm is only dealing with I2, not I1. So although you delete that current source, make sure you leave your little arrows and know where those loops actually were with I1 and I2. So 100 times I2, now I come up and I hit my 5 kilo ohm resistor. That's 5,000 onto I1. That's just I1, right? Okay. And then I had 10,000 onto I1. This guy was I3. This guy was I4. I'm going to be positive for I1, minus for I3. Again, I1's kind of the loop I'm in, but it's just I'm in the loop for both I1 and I2. I'm definitely not in the loop for I3. So it's negative for that, or going the wrong way for that resistor. Then I come down here and I hit plus or minus 25 ohms, 25,000 onto I2 minus I4. That whole equation equals 0. That's my super mesh equation. So it started down here, again hitting voltage plus to minus, which aren't my current ones. Plus to minus voltage here, and then around, plus to minus, but I had to keep up with what was I1 and what was I2. Remember, I had my equation that my I1 minus I2 really equaled that 1 amp source that was there. Okay, now I write my equation for I3. That is just 10,000 onto I3 minus I1. I'm now going to be positive mesh current I3 to go around this way. Positive and hit that resistor 7, and that's 35,000 onto just I3. And now hit resistor 4 and get 20,000 onto I3 minus I4. That has to equal 0. Okay, so this whole guy is one equation. This is equation 2. I'm going to get myself some space up here. Equation 3 I'm going to do for mesh 4. Start down here. Hit resistor 5 plus to minus. That means resistor 5's value is 25,000. Make I4 positive. Minus I2 plus 20,000. Oops, forgot a 0 there. I4 minus I3 plus 30,000 onto just I4 equals 0. I have 3 equations, right? So I have my super mesh and then my other 2 meshes. But how many unknowns do I have? I have 4. I1, I2, I3, and I4. That's because I can't forget this equation here that I had to write based on my current source. Again, that current source was going this way, and it was 1 amp. I just remove it when I write that super mesh, but I had to already write this equation first. Now I have 4 equations, 4 unknowns, and I can do that. It's not even really any harder to put it into my super mesh, into my matrix form on that. So for that, if I wanted to write it in my matrix, remember our trick is that I'll be positive for each resistor that's in that mesh. Now that I have a super mesh for this whole thing, I'll be positive for either I1 or I2. So what's positive for I1? These 2 resistors were in I1. So that's 5,000 plus 10,000. I'm just going to write this as R1 plus R2 here in this case. Okay, they're positive for I1. What's positive for I2? That's R8 and R5. Plus R8. And then what's times I3? This was I3. This was I4. That would be negative, since that's not a mesh I'm in. That super mesh only composed of I1 and I2, not I3. So that's negative R2 for it. And never make enough space in my matrices. Negative R5 for I4. Okay, that's really easy to do that. The other thing I need so that I have my 4 lines of equations is my next line has to come from my super mesh. Remember we said that equation was that 1 amp in this case was going to equal I1 minus I2 from it. That means that what was in front of my I1 as a coefficient is really just 1. If you want to think about it, you could have multiplied this whole equation by 1 ohm, so it's in ohms like everything else, if that makes you happy. That gets you 1 volt equals 1 ohm I1 minus 1 ohm I2. But still, that coefficient in front of I1 is really just 1. Coefficient in front of I2 is negative 1. And then I have no I3s, no I4s. And what it would equal in my constant matrix on the other side is that 1 volt. My other one equals 0. So I can put it into the matrix like that, and that would be fine to do. Okay. My other equations again, R2 and R7 would be positive for I3. So I would have R2 plus R7 in that column being positive. What would be I1 is negative R2, overlaps with I1. And what would be I2? I have actually no I2s there. And then I4 would be negative R4. Oh, I have R2 plus R7, I forgot R4, plus R4 as well. The whole thing is that term. Then my last mesh, which was I4's mesh, would be positive R4, R5, and R6. So R4 plus R5 plus R6 for that last term. And what overlaps with I1? Actually nothing. What overlaps with I2 is R5, negative for it, since that's not the loop I'm in. I3 is negative R4. So that would be my whole matrix for these. So I still can solve them with mesh analysis. I just have to be careful of that current source. If this current source was going the other direction, I'm going to erase it right now, and let's draw it going this way. Then what would that do? Now, if I make my I1 and I2, then is this 1 amp going in the same direction as I1? No, it isn't. So that 1 amp really equals negative I1, but it is now going in the same direction as I2, plus I2. Or the other way to write that is 1 equals I2 plus I1. So I do have to be careful with the sign of those arrows from it. Similarly, in my first example, when I had I1 like this, it was going in the same direction as this current source through that branch. But if I make that current source go the other way, go down, then that would mean for this equation, I1 would equal negative 1 milliamp. So you do have to be careful with your signs. Okay, now let's talk about nodal analysis. Nodal analysis, we said, was basically using KCL, or Kirchhoff's current laws, to look at current into a node has to equal current leaving a node. And that was great and easy when you have current sources and resistors, since what you care about is current. It's harder when you have voltage sources. Again, there are two cases of exactly how hard this is going to be. Case number one is if a voltage source is connected to ground at one end. So for example, this 20 volt source here, one end of it is directly connected to ground. If so, that makes it pretty easy to still do nodal analysis. That just means that the opposite end of that voltage source has a node voltage equal to the value of the source, but again, being careful to sign. So here's my node here, and if I call that node V1, then what does V1 equal? Well, it's just ground plus 20 volts, so it's 0 plus 20, 20. I already know what it is. I don't even have to write it as a separate variable if I want. I can just leave it as 20 volts. But if I have a voltage source in case 2 that is not connected to ground on either end, for example, this 5 volt source over here, this end is not ground and this end is not ground. So I have to do something with it. I get to make what's called a supernode. But before I do that, I get to write an equation for how one node relates to the other based on that voltage source. So let's label the rest of our nodes here. I have one node here. I'm going to call that V2. I have a node here. That's V3. I have a node here. It's V4. The rest of this is already ground. I don't have to write that, and I've already written V1. Okay, so I have 4 nodes. Again, you wouldn't even have to write this as a variable if you just wrote it as 20. Then you could have started calling V2, V1, and going through it that way and having one less variable. But needless to say, I left mine writing that as V1 equals 20. So how do I write how the nodes on either side of this 5 volt source are related to the 5 volts? Well, which side is the higher voltage? This one has the plus, so it means that this side is my higher voltage. That's V4. So V4 equals V3, the voltage on the other side of that node, but 5 volts higher, so V3 plus 5. That's the equation I must write, just like with mesh analysis, that you had to write that extra equation for it. So V4 equals V3 plus 5, and then I get to treat the whole thing, V4 and that voltage source and V3, all together is one big supernode. I'm going to draw this actually, the different color markers. So now this whole thing is a node together, and now I care about currents going into just that whole supernode or leaving that whole supernode. So let's label some currents. Again, directions of these arrows are up to you. I'm going to label arrows going this way. And I'm going to take a shortcut here in this nodal analysis and not call them I1, I2, I3, I4, but just write, when I'm looking at the current, I know that I equals delta V over R. I'm just going to write them as a change in voltage over their resistance. So let's look at node V1. I don't have to write any equations for it. I already know its voltage. Don't have to write equations if you already know the voltage, because that's what I'm solving for. Right? But the rest of them I am going to have to write equations for. So let's look at node V2. Now here's V2. What's going into it? Well, I got this arrow through R3 going into it. It starts at what voltage? It starts at V1. So I go from V1, ends at what voltage? V2 over R3. Anything else going into this node, V2? I don't see anything. Everything else is leaving. So I have the current through R5 leaving. That started at V2, goes to ground, to 0 over R5. I have the current through R4 leaving. So that's V2 minus V3 over R4. And I have the current through R2 leaving. V2 minus V4 over R2. So that's one equation. Label that equation 1. Don't forget we already had this equation from our supernode. That's equation 2. Let's write equation number 3. We'll be looking at node V3 here and V4 as a big supernode. Anything going into it. This guy's going into the supernode, into V4 part of it. How do I write that current? That starts at V1, goes to V4. So, sorry, V1 minus V4 over R1. I'm just going to either write that as 5 coulombs, but to stay the same, we'll call it R1. The current through R2 is also going into my supernode. That starts at V2, goes to V4 over R2. Again, it's important to remember which voltage is still which. It's not that the supernode is all held at the same voltage, but I get to write only one equation for what goes into the whole thing. Anything else going in? Yeah, over here at this part of my supernode, R4 is going in. That's V2 minus V3 over R4. Oh, and I'm missing a current down here. I'm going to make him go this way. So that's all that's going in. I'm going in here. All of the possible places branches hit the supernode. But what's leaving is then V3 minus ground, so minus 0, over R6. Sorry, that was V3 minus 0 over R6. For that whole equation, if you can't see that. So that's my supernode equation. That's my third equation. I have 4 nodes though. What's the one I'm forgetting? I forgot that V1 is just 20 volts. So that's really equation 4. And you could have made this into just 3 equations and 3 unknowns. If anywhere in place of V1, like right here where I had a V1, I just write 20 volts instead. That would have been fine. Okay, so that's how I do nodal analysis with voltage sources and mesh analysis with current sources. Please do some practice problems from the book using nodal and mesh analysis to get yourself familiar with them. Good luck, guys.